So what I want to talk about this afternoon, what I want to do this afternoon is to finally move on to a discussion of the other two time asymmetries that we mentioned, the other two time asymmetries of our everyday empirical experience of the world that I mentioned at the outset, that is the asymmetry of epistemic access and what you might call the asymmetry of causation or the asymmetry of intervention or something like that. Like Shelley said, I think, yesterday morning, a lot of people might react to questions about the origin of those questions. A lot of people might react to requests for a mechanical explanation of those. Particularly, I guess, the causal one, although maybe the epistemic one too, as prima facie a puzzling request. That is, it might at first blush be difficult to imagine what there could be to say about the fact that we remember the past and not the future, other than to repeat the banality that it's the past, okay? And similarly to questions about our capacities to affect the past and the future. That is, I take it the thought might be that these sorts of asymmetries just don't present themselves on the face of it as the sorts of things that are even susceptible to being understood as mechanical phenomena of nature. Maybe in more detail, the thought might be that that the business of the natural sciences, and this I guess would go hand in hand more with a governance understanding of law likeness than with a descriptive understanding of law likeness. That the business of the natural sciences is to discover the fundamental laws and mechanical processes whereby the past shapes or produces or gives rise to the future. And if you ask about the fact that it is the past that gives rise to the future, and rather than being the other way around, the thought might be that that's another thing entirely. That's something that's in some way prior to and deeper than and outside of the proper jurisdiction of scientific explanation. Something that amounts to a condition of the possibility of scientific explanation. Something that, if you're going to reflect on it at all, ought to be a candidate for a different kind of investigation. Not a scientific investigation, but maybe the business of conceptual analysis or linguistic analysis or phenomenological analysis. But not a proper subject of study for the natural sciences at all. I don't mean to be putting all these words in Shelley's mouth, but that's a sort of riff on one way of being puzzled by such a question. And it's exactly the possibility of being puzzled by such questions in precisely such a way that it seems to me makes them exciting to press. Because if you do end up with a satisfying scientific, with a satisfying mechanical explanation of these phenomena, you've in some way expanded the domain of scientific explanation beyond the point where it was obvious to everyone that it applied. So anyway, that's part of what makes this, presumably in the case of the thermodynamic asymmetries, there isn't any question about whose business it is to explain those. It's the business of physics. With respect to these other two asymmetries, it may be less clear that that's the case. But certainly the line I'm going to want to press is that it is the case. And that moreover, we have in hand the outlines, or at least some element of the outlines, some elements of the outlines of the kind of form that such an explanation might take. Okay. Let's start off with the one that's, from the point of view of this metaphysical puzzlement, easier and more natural to try to explain. That's the asymmetry of epistemic access. So, let me distinguish first, just as a logical matter, between two different imaginable procedures for making inferences from information we have about, say, the present, or about one particular moment in the history of the world, to physical condition of the world at other times. So here are two different procedures which have different conditions of applicability and yield different sorts of results, and so on. Here are two different procedures for making such inferences. First procedure, let's make up a technical term for it. So let's call the first procedure prediction if it's oriented toward the future, or retrodiction if it's oriented toward the past. Here's what that procedure is. You take whatever it is you happen to know about the present state of the world. Okay, that will correspond to some chunk, perhaps disconnected chunk of phase space. And you simply follow the following procedure. You put a probability distribution over the exact microconditions compatible with that chunk, which is the usual statistical mechanical one, that is the one that's uniform over the standard volume measure in phase space. Okay? And then you just plug that distribution into the exact microscopic dynamical equations of motion, evolve them forward if you're doing retrodiction, evolve them backwards, evolve them forward if you're doing prediction, evolve them backwards if you're doing retrodiction. And you've got yourself a bunch of claims about the probability that certain events occur in the future or in the past. We happen to know that yields very good results toward the future. Indeed, I think it could be argued that if you take proper care in fleshing out the meanings of all the terms in this statement, it's the case that everything you take yourself to have good reason to believe about the future, on reflection, coincides with the totality of what could be inferred by means of prediction from the totality of what you take yourself to have good reason to believe about the present. We know that with retrodiction the case is very different. That's what we've been talking about for much of the past 2 days. But anyway, that's one procedure. That's the procedure of prediction/retrodiction. Here's another procedure. This procedure, note, has the following logical structure. You start with information, all of which is about one time, okay? And then you use the dynamical equations of motion to make inferences about times temporally removed from that time that you start with. Here's a procedure with a very different sort of logical structure. Call this, rather than inference by prediction or retrodiction, inference by measurement. Okay? The logical structure of inferences by measurement is that they don't start with information, all of which is confined to one time. Okay? They start with information about the condition of the world, radically incomplete information. But they start with information about the condition of the world at two different times. Okay? And then you make inferences, typically, from those two different times, using the equations of motion, about the situation of the world at various times in between them. Okay? I'm sure it was obvious to lots of people in lots of other fields for a long time, but it became very vivid, I take it, in Foundations of Physics in looking into the measurement problem in quantum mechanics, which we're going to talk about later in the week, that good measuring devices aren't the sorts of things that, as a result of interaction with the system they're designed to measure, get into the proper indicator states. They're the kinds of, there couldn't be something, it's not in the structure of the dynamical equations of motion to allow there to be things like that. What the dynamical equations of motion allow is that if you have is that certain kinds of systems, if you initially prepare them in a state, their ready state, the state where they're plugged in and properly calibrated and facing in the right direction and all ready to go, if you initially prepare them in this ready state, then allow them to interact with the system that you're interested in measuring, they will thereafter end up in what you might call a record-bearing state, which, given that they were prepared in the ready state, is something from which features of the measured system at the time in between those two states can be inferred. So that the information that you do your inferring from in the case of a measurement is not just the final state, but as it were a relation between the states of the measuring instrument at two times. Okay? And that's why we call more generally a procedure of inference about the physical condition of the world at a certain time from information about its conditions at two other times, inference by measurement, as opposed to inference by prediction or retrodiction. So far, we've just given a couple of definitions. Nothing substantive about the world has been said. I hope the definitions are clear. Okay.
Would you clarify that the first category, prediction, seemed to me you were saying two different things. What I personally may know some of the equations, or I have some of the information, but obviously I don't have it all, or have as much as science does.
Well, wait, no, I'm not sure. No. It's not
You're talking about science in general?
No, first of all, yeah, I'm taking it for granted that we know exactly what the dynamical laws are. Okay. What we usually don't know exactly, and of course it's not true that we know exactly what the dynamical laws are, we'll only know what those are at the end of scientific inquiry, so on and so forth. I'm saying suppose the dynamical laws are given. Okay. Then we start with a certain finite amount of information about the actual physical state of the world now. Say it's macro state, or typically much less than that, because we don't know the macro state of the world, on other planets or something like that. But you take some information, whatever information you happen to have about what the state of the world happens to be now. The way you draw inferences from that about the state of the world at other times is by putting the uniform probability distribution over the stuff that you don't know, plugging that probability distribution into the microscopic equations of motion, and evolving it forwards or backwards, depending on whether you're doing prediction or retrodiction. Okay, good. Here's a really interesting thing to notice. There are all sorts of situations in which inference by measurement can be breathtakingly more powerful, breathtakingly more informative than inference by prediction or retrodiction. Let me give you a simple toy example of what I have in mind. So suppose I have an isolated system consisting of a collection of billiard balls rolling around frictionlessly on a table or in outer space or something like that. I don't care. Good. suppose that, suppose that I'd like to know whether or not it's going to be the case over the next 10 minutes that billiard ball number 5 is going to be involved in a collision with any one of the other billiard balls. Okay? The way I need to do that, to do it by prediction, is going to involve a procedure that requires that I input the position and velocity of every billiard ball on the table into the equations of motion and evolve them forwards. Okay? And see whether there are any such collisions or not over the subsequent 10 minutes. Note that, suppose on the other hand that it were the case, and of course exactly the same thing would be true toward the past, to draw this conclusion by means of retrodiction. That is, as the number of billiard balls goes up, the complexity of the input in terms of initial conditions is going to get higher and higher. The complexity of the calculations is going to get higher and higher, so on and so forth. Suppose, on the other hand, that I happen to have an additional piece of information about the history of the world, to wit, billiard ball number 5 was moving 10 minutes ago. It wasn't stationary relative to whatever frame of reference I happen to be using. Okay? Good. Then, as a matter of fact, trivially, it follows that if billiard ball number 5 now is stationary, necessarily it was involved in a collision over the past 10 minutes. Everybody with me here? Okay? Or if it's moving at a different velocity, maybe I have more information about exactly how it was moving 10 minutes ago or something like that. And if its velocity is now is different from what its velocity was 10 minutes ago, it follows that it was involved in a collision over the past 10 minutes. Okay? Note that, first of all, the simplicity of this inference is completely independent of how many billiard balls are involved in the system. All kinds of stuff like that. Okay. You're given a single sort of binary piece of information about some other time, namely that billiard ball number 5 was moving 10 minutes ago. Okay. Then it can be inferred from the fact that it's stationary now that it was involved in a collision over the past 10 minutes. This is something which, if you try to deduce it predictively or retrodictively, would involve a really complicated calculation, would involve fairly detailed knowledge of the positions and velocities of all of the billiard balls on the table, so on and so forth. Everybody with me here? So the first point is, there's a really vivid difference between the way the logic of inference in prediction, retrodiction works, and the way the logic of inference in inference by measurement works. Everybody with me? Okay. Let me point out something else about inference by measurement. Shift the way we've been talking a little bit. Suppose I have a piece of, I have information to the effect that billiard ball number 5 was moving 10 minutes ago, and billiard ball number 5 is stationary now. We've been thinking of this as some kind of record of something happening or not happening to billiard ball number 5. Of course, we could equally well think of it as a record of something happening or not happening to at least one of the other billiard balls in this collection. Okay? That is, these two pieces of information can be used to infer that one of the other billiard balls in the collection was as it were on a collision course with billiard ball number 5, given the way billiard ball number 5 was moving 10 minutes ago. Okay? So it can be thought of not as a registration of something that happened to billiard ball number 5, but as a registration of something about the condition of some of the other billiard balls. And if we wanted the registration to give us more information than that, we could modify the example in such a way that, for example, the interactions of billiard ball number 5 with various of the other billiard balls varied according to which billiard ball it was, or were switched off and on at certain times during the history of billiard ball number 5, so on and so forth. And the more such refinements we added, the more information we would get about the conditions of the other billiard balls in this collection from these two pieces of information. And we could refine those conditions up to the point where we had the equivalent of a photograph of the immediate neighborhood of billiard ball number 5 at a certain moment in the past, or something like that. Okay, and what I want you to notice about this, and this is a really vital difference between prediction, retrodiction on the one hand, and inference by measurement on the other hand, is that what happens in cases of, or what's possible in cases of inference by measurement, is that you can be in a position to infer something, say, about the position of billiard ball number 12, okay, at a certain time during the past 10 minutes, in a way that is not parasitic at all of your having any idea whatever what may have befallen billiard ball number 12 during the interval between the time your registration refers to and the present. Okay? That is, once you have this information, as long as you're confident that you know what was affecting the motion of billiard ball number 5 during that interval, between the time that it interacted with billiard ball number 12 and the present. You don't need to know a thing about billiard ball number 12. Billiard ball number 12 might have been destroyed or ceased to exist or blown up or turned into an elephant or anything you like. Okay? This is never a characteristic of prediction or retrodiction. Okay? In cases of prediction or retrodiction, what you know about a certain system S at a certain other time is always parasitic on your having an idea of the laws and forces and external conditions under which system S is evolving, under the influence of which system S is evolving. The idea is that in cases of measurement by inference, okay, all of that stuff that you need to know in cases of prediction, retrodiction about the system itself can be displaced onto whatever other system is carrying the information about the system that you're interested in. Is this distinction clear? Any questions? No? Okay. Good. Good. But look, at the end of the day, the kind of thing to which we usually allow ourselves to imagine, you know, at the end of the day in a game like this, the rules of the game are you usually allow yourself the fantasy of having sort of direct and unproblematic epistemic access to features just of the present. Okay? And what you want to know is what that kind of epistemic access can be parlayed into by means of the laws of physics. Okay? So in cases of inference by measurement, where you're depending also on some claim about another time, the question is naturally going to arise, well, how did you get epistemic access to this piece of information? Okay? And the answer is usually going to be, oh, I had some other measurement with conditions before and after. I have some other record of that having been the case at that earlier time. But then a question is going to arise about how you knew this, and so on and so on and so on. Okay? And the question is whether, and if so, where this kind of regress is ever going to terminate. Okay? The question is whether, and if so, where, you're finally going to run into some claim about how things were at some other time, which has more of the status of something like a law, or a posit that's taken for granted in all of our reasoning about the world, or something like that. Okay. And the thought, in light of what we've been discussing over the past day and a half or so, is that there is in the structure of statistical mechanics that we've laid out a very natural candidate for such a mother of all ready conditions, as it were, sitting in the past hypothesis. Okay. The past hypothesis amounts to a very severe limitation that is an enormously rich amount of information about what the remote past of the world was like. Okay? And the thought is, okay, that in some ultimate sense, certainly not in a sense that reflects at all what goes on in our conscious reasoning about looking at records. Often we make inferences from records without any conscious reasoning at all, so on and so forth. But in some ultimate sense of logical relation, okay, what's playing the role of the ultimate ready state in all of the sort of inferences by measurement that we do is the past hypothesis, okay, is the claim about the initial condition of the universe. Okay. And if something like that is right, okay, then we have a clear explanation of why it is that this kind of regress can be terminated in what we call the past direction, but can't ever be terminated in the future direction. Okay. We have an explanation of why it is that we have epistemic access of this measurement type only toward the past, and that all we have toward the future is epistemic access of what I'm calling the prediction type.
I sure didn't follow the logic of that. I understand what your conclusion was, I just don't see how you got there.
Can you be a little more specific?
Well, you said that if we could get the point of...
So here's the, let's see, here's the picture.
You know, probability destruction at some ultimate...
Here, let me say it a little differently, see if that helps. So look, the picture we sort of finished laying out this morning of the sort of general structure of the laws of the world, okay, was essentially this. The laws of the world, the general principles of inference or of reasoning by means of natural law that we have has three basic constituents: the microscopic dynamics, the past hypothesis, and the statistical postulate. Okay? That's what there is. Okay? That already, that is the presence of the past hypothesis and the application of the statistical postulate only at the point where the past hypothesis applies, of course, introduces, I mean, maybe this is something we should have said before. So look, once we've set up this structure, what's the answer to the question of how the time asymmetry actually gets into the world? Okay. Answer, the past hypothesis. Okay. The past hypothesis very explicitly and by hand introduces a time asymmetry into the fundamental laws. It doesn't introduce it at the level of the dynamics. It introduces it in the form of a non-dynamical law. This past hypothesis, which stipulates that which gives you a lot of information about the state of the universe at some very early time, and tells you, moreover, that that's the point at which the statistical postulate ought to be applied. Okay, that's the origin. If someone asks, to what fundamental features of the world, can the time asymmetry of thermodynamics ultimately be traced back? The answer is the past hypothesis. Okay? And the thought here is that at the end of the day, the asymmetry in our epistemic access to the past and the future can be traced back to exactly the same feature of the world. Okay? The past hypothesis makes it the case that in one temporal direction, there is an available endpoint for this regress. Okay? And in the other temporal direction, there isn't. Okay? So that you can perform inference by measurement in the direction of the past hypothesis. That is, you can perform inference by measurement about those regions of the world which lie in between the past hypothesis and the present. Okay? But not on the other side of that boundary. Okay? And that the big difference between our epistemic access to the future and our epistemic access toward the past is that toward the past, inference by measurement is available to us because of the past hypothesis.
Maybe
And
it's
toward
not
the
good
future,
to
it's
call
not.
it. Maybe it's not good to call it at the end of the day, though, inference by measurement, because there's no
Oh, I'm
measurement.
sorry. I thought you were saying, I'm sorry, say
No,
something
maybe
else.
at the end of the day, though, it's not good to call this thing inference by measurement, because there's no measurement associated with the past hypothesis. That's
No.
it.
I'm sorry. Maybe inference by measurement is a bad name, although...
I mean, it was useful in getting to the
Here's the
story.
motivation for it.
No, I saw the motivation.
Right, okay. You got a suggestion?
No, I don't know.
Two-pronged inference. I don't know. Okay.
Yeah, but it is going to cause people to say, okay, so
Maybe
there's
so.
the guy who thinks we had to observe.
No. That's exactly what we didn't have to do.
Yes.
Right. That's exactly what we didn't have to do. That's exactly what we didn't have to do. Yeah.
Can you say more what you mean that inference by measurement is available in the past?
Yeah, I mean toward, suppose I say toward the future, okay? If I only knew what this billiard ball was going to be doing, if I only knew that 10 minutes from now the billiard ball is stationary, I would be able to infer from its present motion that it's going to be involved in a collision over the next 10 minutes, okay? And I wouldn't have to factor in the positions and velocities of all the other billiard balls on the table. I'd be able to do it in a simple, straightforward way. So if only I knew that, I'd be in great shape, okay? And somebody says, but how would you come to know that? The guy says, well, maybe I could know it because there's some other object, okay, that's sensitive to the motion of this billiard ball, which has a state later and has a state now. And if I knew its state later, I could infer from its state now that this billiard ball is moving 10 minutes from now. That's how I would know. And then the guy would say, fine, but how would you know about this state of this other measuring device billiard ball, and so on and so on and so on. These questions can continue ad infinitum, okay? Nothing is going to put a stop to them. There isn't any other general principle of our reasoning, okay, that's somehow going to say, there's something I have a right to assume about the far future,
I
okay.
think I'm just the person who's really worried, like the person who really doubts the records. In what sense do I have the right to assume the past hypothesis? Because, on a very, very practical level, there would be.
So let me see if I understand the question. If there's, of course, and this is something that doesn't apply just to this, it applies to science in general. Nobody's presuming that they have a way to refute radically skeptical doubts, or maybe the world doesn't exist, maybe we're dreaming, maybe all of our records are, but maybe that's not what you're asking. I'm not sure I do understand what you're asking. If the worry is about how to arm ourselves, fully against radical skeptical doubts, the simple answer is there's no way to do that. The claim is that, maybe it's worth saying a little bit more about the epistemic status of the past hypothesis itself, okay? So here's the deal. this usual game of sort of substituting for what we don't know the uniform probability distribution, the probability distribution that's uniform with respect to the standard phase space volume measure, over all of the microstates compatible with whatever it is that we happen to know. Okay? Good. And that produces a disaster for three reasons. Okay? That is, that produces typical trajectories through. So suppose this is the current macro state of the world, or what we know of the current macro state of the world. That produces, according to the Boltzmannian argument, these kinds of trajectories toward the future and toward the past. And there are three problems about those trajectories. One, this isn't what we think happened in the past. Okay? This isn't what the memories that are present in this macro state portray the past as having been like. Two, it puts us in this cognitively unstable position, okay? Because one of the things that's contained in this set of memories are our reasons for believing in the truth of the microdynamical laws in the first place, okay? So the position is somehow self-undermining, okay? And then third, which is not so important for us now, is this mathematical contradiction, that it couldn't be that every point down the trajectory is an entropy minimum. Good. Concentrate on the first two, okay? We say, well, suppose we added an additional stipulation to the fundamental laws to the effect that the entropy a long time ago was very low, okay? Good. What's the nature of that additional stipulation, okay? That is, what's our epistemic relationship exactly to that stipulation? It isn't quite right to say we know it by observation, okay? Because look, all of the observational evidence for something like this, all of the normal cosmological observational evidence for something like this, is contained in this macro state, okay? If you ask, just given the existence of this observational evidence, okay, plus the usual statistical mechanical methods of calculation, what's the likelihood that this evidence is actually evidence for the existence of a state like this? The answer is minuscule, okay? There's almost no chance that it actually came about as a result of the state that it apparently portrays actually ever having obtained, okay? What is the likely way that it came about? It fluctuated out of the void, okay? How can that possibly be more likely than it's being a veridical record of what actually happened in the past? Oh, because this state, if you calculate likelihood just by measuring, just by the standard statistical mechanical stuff, the entropy of this state is so low, okay, that the probability of a trajectory like this is much, much lower than the probability of a trajectory like this, even though a trajectory like this itself has rather low probability, and much more likely is just a trajectory like this, okay? But given the fact that we have this, the most likely way that this was produced was by a fluctuation. Okay, good. This, however, is a mess. Okay, it's cognitively unstable. Okay, it refuses to validate even the sorts of memories that are crucial for our giving an account of why we believe the dynamical laws in the first place. The whole thing is a mess. Okay. So we posit as a sort of additional fundamental law, there was this low entropy state a long time ago. Okay. It isn't quite right to describe that posit as our observing that that's the case. Because it's the veridicality of these kinds of observations that's exactly what's in question here. Okay. What we know is, if we add this, everything else falls into place. Everything else suddenly hangs together. The stuff that we take to be evidence for the truth of the physical laws is evidence for the truth of the physical laws. Our memories, or at least the ones that are formed in the way we usually regard as proper formation of memories, are likely to be veridical, blah, 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 blah. Okay? So, So this posit has a sort of funny epistemic status, okay? Its epistemic status is more like the epistemic status of a fundamental law of nature, okay? That is, we posit it because it works well, okay? Because it makes good predictions. Rather than the epistemic status of, say, my belief that a chair is in the room now, okay? That's the deal, okay? It has a funny epistemic status. It's not something we believe as a result of having direct observational evidence for it. It is situated much more deeply in our whole structure of reasoning about the world than that, okay? I'm not sure I know how to say it positively exactly what its epistemic status is, but it's different from the epistemic status of my knowledge of, say, there being a chair over here, okay? It's not something that we believe because we measured it or we believe because we saw it in some direct sense. It's something that we believe, at least in part, because if we didn't, the whole structure of our reasoning collapses around our angles, okay? Yeah?
Would you say that it has the same status with cosmological principles?
I think it has a similar status to a fundamental law of nature. Okay, that is, I think
Well, can you do experiments? Would you assume that?
in the same sense that we can with laws. That is, there isn't any such thing as a crucial experiment which shows that these are the laws and those aren't. There are always assumptions and so on and so forth. But it forms part in the Jungian language. Okay. This posit forms a crucial part of this best system, of what God is going to put on the T-shirt, okay? If he wants us to, if he wants to communicate as concisely and as informatively as possible with us about the way the world is, okay?
David, I mean, do you, at the end of the day, do you think we have evidence for the
You
past?
told me not to say at the end of the day.
Yeah, okay. Do you think we have evidence for the past hypothesis? I guess you must think we do. And number two, keeping the past hypothesis and everything else aside, from what we know about by looking around,
Right,
which is in that macro state, of course,
right.
do you think, would it be fair to say, forget about the past hypothesis, that we have evidence that there were dinosaurs when we see dinosaur bones in the ground?
I mean, sure. The nature of the crisis produced, the nature of the crisis that you're in without the past hypothesis is precisely that without the past hypothesis, dinosaur bones don't constitute any kind of evidence at all for the existence of dinosaurs.
That's a striking view.
Well, wait, I don't understand. I mean, it may be striking. So let's put it this way. Here's what I mean by in the absence of the past hypothesis. I just mean the system that I have with the past hypothesis subtracted.
Right, that's correct.
Yes.
But
yes.
There's another
That's
sense.
all I meant.
Yeah, but there is clearly a sense that the man.
No. You could take an entirely different approach of some kind.
No, and everybody would.
Yeah.
Okay.
Wait. No. I'm not sure I understand.
No, it's not an abuse of language to say that when you see dinosaur bones, we have evidence they're dinosaurs.
That's absolutely
Somehow that's absolutely right.
That's absolutely right. And what one can do, and what one often does in science, is to grant that that's obviously true, and then become curious about what the world would need to be like in order for that.
No,
to be
I don't
true.
disagree with any of the more technical
Right,
stuff.
right, good.
It's just on the use of the word evidence.
No, but that's absolutely right. That's absolutely right. And what's going on, part of what's going on in an inquiry like this is precisely an inquiry about what else it is about the structure of the world that we're committed to when we commit ourselves to claims about dinosaur bones being evidence for the existence of dinosaurs. Yeah.
Just a comment on the previous question, does the cosmological principle have the same status as the past hypothesis? I would say it definitely doesn't, because the cosmological principle is more about the present state of the universe. Is it homogeneous? Is it isotropic? And that's something that you can test right now in a way that you have to.
But I also would, the business is subtle here. It certainly wouldn't be appropriate to say that the past hypothesis is the kind of thing you can't test. Okay.
You would test it, but
It's that your epistemic relationship to it is more like your epistemic relationship to fundamental laws than it is like your epistemic relationship to this chair being here. Of course we think we can empirically test fundamental laws and so on and so forth. And in the same way, we can test the past hypothesis. Does it give us good predictions? For example, I see a couple of hands. Just hold on 1 second. Just want to assure you that I'm not forgetting about you. Here's an example that Feynman comes up with in his, why do I keep forgetting the name of this?
Character physical
The
law.
character physical law. I'm surprised I remember my name at this point. Maybe I don't. Anyway.
What is the name?
Anyway, here's a nice example that Feynman comes up with. Look, suppose I'm digging around in my garden, or I guess it ought to be a garden in Europe somewhere, or in Corsica. I'm digging around in my garden, and I find a boot with a fancy N embroidered on it, of the kind that Napoleon preferred. Good. And now I ask a question, which is on the face of it, a request for a prediction about the future. If I dig around some more, what's the likelihood of my finding a second such boot somewhere in the vicinity? Okay. Well, if I regard the present state of the world, including the discovery of this first boot, okay, in this way, okay, then it's that is, if what I do is just predict and retrodict in my earlier language from the present state of the world, it's very unlikely that Napoleon ever existed. The existence of the boot I found is much more likely to be a fluctuation, okay, the result of a fluctuation, than it is likely to be related to the existence of a historical figure named Napoleon. Okay? So that if I calculate without the past hypothesis, the probability I ought to assign to finding another boot if I dig around some more ought to be very, very low. Okay? On the other hand, if I add the past hypothesis to the picture of my fundamental laws, that changes everything. Okay? In that case, the most likely scenario for the appearance of this boot has to do, presumably, with the existence of a historical figure named Napoleon, preferred embroidery of that kind. And the prediction I get is that if I dig around further, the chances of my finding another boot of Napoleon are very high. Okay? It's the second sort of prediction that's borne out by our experience of the world. This is the way in which we confirm things like the past hypothesis. Very much analogous to the way we confirm things about other proposals for fundamental laws of nature. Yeah?
Yeah, well, I mean, but with the radicality of our memories is one there in question. I mean, then argument for possibilities in this sort of inductive predictive manner, I mean, the reasoning seems to be viciously circular, because we only think that we, in fact, make these predictions on the basis of our memories and...
Yeah. It's, no.
It doesn't seem that kind of reasoning is going to work.
No, wait. It depends, work from where? That is, no amount of reasoning like this, okay, is ever going to imply by some kind of Bayesian conditionalization that suddenly the most likely thing is that the past hypothesis was true. That's right. Even if after I have the two boots, okay, so I'm at this stage, okay, I inquire into the most likely past of that state, it's going to look like this, okay, where Napoleon also didn't exist, but two boots simultaneously fluctuated out of the void. That's absolutely right. So it's never going to be the case that there's going to be some procedure of Bayesian conditionalization, okay, on the present evidence. Well, let's put it this way. If the probability distribution you start with is the one that's, if your prior probabilities, say, are uniform over the entire space of possible microstates of the universe, okay, then no procedure of Bayesian conditionalization like this is ever going to make this likely. If your priors were a little different, okay, and this is something Feynman mentions also, if your priors just gave a slightly heightened initial probability to the initial state of the universe having been low entropy, then these discoveries are going to raise that probability very, very quickly. Okay? Or the better way to say it is, don't think about arriving there starting from nothing or starting from a uniform probability distribution by Bayesian conditionalization. Approach it differently. Ask if there's a fundamental scientific model of the way the world is. Here, I take it, is a reasonable principle of scientific theorizing. You give up only on those features of the manifest image of the world. You give up only on those features of what the world looked like to you before you started your scientific theorizing. You give up only those features of that picture of the world which you're forced to in a fairly compelling way. Okay? You don't give up features of your original conception of the world willy-nilly, because then you just have no clear place to start from. Okay? There's some kind of principle of conservatism in scientific theorizing, which seems to me an absolutely appropriate way to proceed. Okay? You give up those features of the world which discoveries you make compel you to give up. You give up those features of your original picture of the world, which discoveries you make somehow compel you to give up. Okay? What you should be doing here from the word go is seeing whether there's a scientifically respectable way to hang on, to make all of these things hang together. Okay? And the good news is that it turns out that there is.
Yeah,
Okay.
I wouldn't say that you're arguing for it on predictive or inductive grounds. I mean, I'd say you're arguing for the past hypothesis on the basis of like transcendental grounds. Like it's needed to preserve the truth of our memories.
But it's not, I don't understand. It's not only that. It's also a theory. It's also a theory that if I adopt it, makes good predictions about the Napoleon boot case and so on. Okay? It seems to me to say that the argument for it is completely transcendental is
It's partially transcendental.
a way of presenting the argument is transcendental. There's another way of presenting the argument that makes it look much more like, if you start out with a uniform distribution over all possible scientific theories, nothing's going to get you anywhere. Okay? You start out with a distribution over possible scientific theories, with a set of priors over possible scientific theories, which is very much influenced by your pre-scientific image of what the world is like. Okay? And you get farther and farther out in this distribution only as you're forced to. Okay? If you ask what's going to endorse the largest part of your pre-scientific picture of what the world is like, it's this one. Then you ask, are there any scientific problems with that? Are there any reasons why I couldn't adopt that responsibly as a scientific theory? If the answer is no, that's a very nice scientific theory. Yeah, Craig.
I want to follow up on this point, and I think it also relates to Shelley's point about evidence. It does seem to have this kind of transcendental character, your argument, and it seems more like, when you said to Shelley about the evidence, about dinosaur bones,
Right.
or consider I just look in the telescope and look at a star in the past, so it seems like that's good independent evidence
Right.
that there's
Right.
some kind of low entropy thing in the past. Now, that then wouldn't count as evidence if something like the past hypothesis, if this kind of skeptical scenario is not ruled out, then those things don't count as evidence.
Right.
But then it seems that's what gives it this transcendental character that, your evidence, what you take to be evidence, wouldn't count as evidence if the skeptical scenario weren't true. But then it makes me think, well, there are other assumptions that I need to make for the evidence to be counted as evidence too. Like that there's an external world or all sorts of other things.
Right.
I don't think of those things as themselves, the explanation for, the knowledge asymmetry or the asymmetries. I think of them as just more like, necessary conditions for the evidence to be evidence rather than sufficient conditions for the asymmetry to be there.
Right.
And hold on one second more.
Okay.
In response to the transcendental claim, you said, well, it's not just transcendental because you get a whole lot more. Well, it's not so clear you get a whole lot more because you don't, since you haven't actually specified the past hypothesis state, you know, all you really know are, I mean, so the transcendental argument is more like, well, it better not be, you know, one of those nasty, you know, it better not be, you know, one of these skeptical, nasty, skeptical scenarios. It better be, you know, something else. You only get more if you actually were to, you know, specify what that state is. So we don't really know.
You don't get more unless you, until you
really know you're going to get the second boot. You know,
Right.
Unless, you know, you circle the bit such that most likely you're going to get the second boot.
Right. I'm
So
sorry.
you only get more,
Yeah.
you know, I guess what I'm trying to say is you only get more, I mean, it only seems to beat it only seems to be more than a transcendental type of move, but then I would say it was more like a necessary than a sufficient condition. If I, you know, actually specified the state, actually.
Well, wait, I'm not sure I understand. It sounds like you were willing to grant that you get the second boot, even without a very precise specification of this macro state.
No, because, yeah, so how do, I only get this, there are regions I could pick such that I get the second boot. That's true.
Yeah, well,
But it's not like you've independently specified the thing, and then we've gone and checked to see whether most of the trajectories take you.
Oh, no. Once again,
So it's not like you really get.
This is our situation in
No, it's
statistical
really
mechanics.
getting
No, of
prediction.
course not.
So it really
All
is
we've
just the
got,
transcendental.
all we're going to have, okay, are arguments that go more or less, and all of this is by inches, in the direction of making certain things plausible. That's what we're stuck with here. I wish I could solve the equations of motion, or I wish you could, or I wish somebody could. We can't. That's not going to happen. I mean, I'm given that that's accepted and on the table. I'm not sure what the structure of the complaint here is. We want to do what we can to make these claims plausible. We want to do what we can to license ourselves to say, as far as can reasonably be inferred, that looks like something that would, in principle, if we could do all the calculations, give us what we need. I'm not sure. I'm not sure what more you're going to want of a foundational theory than that. Yeah.
I'm really confused because just when it sounds to me like it's a transcendental argument, you say it's more than that, it gives a more accurate future prediction, but then when you go there, you say, even when you do find the other book, the probability is higher that it had a past trajectory that's different from the one.
If you, let's be careful. Let's be careful here. Let's do the Bayesian conditionalization right. You start with the following prior, okay? The present microstate of the universe is equally likely to be, or, you know, it is the probability of any particular chunk of the phase space now obtained before any observations are done is the one that's given by the unit, if this is even mathematically well defined, but forget about whether it's mathematically well defined, is the one that's uniform with respect to the standard volume measure of phase space over the entirety of phase space, okay? Over every physically possible micro condition, okay? Good. You start out with that. Your eyes are closed. That's what you start out with. Even that isn't consistent because you know there's a U. But, you know, forget about that, okay? Your eyes are closed. That's the prior you start out with. The prior that's absolutely uniform over the entirety of the phase space, okay? If you then can, and for some reason God has told you that the equations of motion are such and such. That's not something you need to learn by looking at the world. That's the game. It's a very artificial game. That's the game we're playing. Okay, good. If you start with that game, okay, then you open your eyes, you see A. Okay, then what you get from the dynamics is something like this. Okay, you dig around a little bit, you see a boot. That puts you in state B. Okay, That gives you a lot. That gives you a likely trajectory like this. Okay. You dig around a little more, you find 2 boots. That puts you in state 2b. Okay. You are narrowing things more and more and more. Okay. But it's still going to be true, since each of these is a non-equilibrium state, that what the Boltzmann arguments are going to give you about the future and the past is still something like this. Okay. There's no conceivable amount of macro information. If you observed so much that you finally knew the exact micro condition of the world, okay, then of course that might snap you back to a trajectory like this. Okay. But there's no conceivable amount of macro information that you could get about the world that's going to change the shape of the trajectory from this. That's the strength of the Boltzmannian argument. Okay? So it doesn't matter if you find his boot and his sword and his hat and his skull, okay, and anything else you want. Okay? It's, once again, at a certain level, okay, when you approach something like fully detailed micro information about the universe as a whole, then of course that's going to start to get you back to a trajectory that looks like this. Okay? But nothing in the way of discovering additional boots or swords or cloaks or
And
hats
that's when you
or
have
skulls.
to appeal to transcendental like argument.
Well, that's I mean,
Because
so,
it's in the absence of the exact total micro conditions of
you could put it in a different way, though. I don't know. It seems to me you could put the whole thing in a different way. You could say, who the hell told you to start out with this uniform probability distribution? Okay. Where is it written in stone that that's the probability distribution that you need to start out with before you open your eyes and begin the whole process of Bayesian conditionalization? Feynman suggests, gee, wouldn't it be more reasonable to give a little preference? I think the way Feynman puts it, is to give a little preference to initial states of the universe that could be described, the macro states that could be described in less space than an encyclopedia, or something like that. And he says, I imagine rightly, that the minute you do that, the discovery of these boots is going to start to favor something like the past hypothesis very, very strongly, very, very quickly. By Bayesian conditionalization. So just to make it clear, the game we were playing before was assuming we were starting out with this prior, which is absolutely uniform over the entire phase space of the universe. Okay? And what you get, and if that's what you start out with, no amount of conditionalization on macroscopic facts about the world is going to get you back to this.
So the empirical part of this is like the how much detail you know you can squeeze into the.
Well, I don't know how to say what the empirical. I prefer to turn the whole thing around, not to ask about how you infer this, to point out that if somebody makes this proposal, okay, and you start to evaluate it and you start to see how well it functions as an explanation of what you see that it functions really well.
On the other hand, on the other side, though, I suppose I'm not to agree with you, I disagree.
Right.
I mean, suppose it's kind of unrealistic that you would actually have this hypothesis about uniform, but suppose you did have it. That's
right.
Some theory, okay, you got it.
Right.
And, you find this boot.
Right.
And then you say, but according to this theory, the probability of finding another boot is insignificant.
Right.
But then I go and look and I find the other boot and say, hey,
Right.
hold on, something's wrong here.
Right.
I better change my mind about what the correct theory is.
I agree.
This is just normal science.
I agree. I think that's exactly the right way to put it. Tim has been championing it a bit for a while.
This thing keeps jumping around. There's this talk about transcendental fancy things. There's a normal thought that we have pretty good observational evidence for what the early state of the universe was. We go to a lot of trouble to get it, involved building telescopes,
Right.
and building better telescopes,
Right.
and building models, and
Right.
stars forming. And
Right.
blah, blah, blah. So to just sort of say, gee, somehow we don't have the kind of observational access to the early state of the universe sounds odd, right? Now it looks like, well, we're trying to rule out an epistemic approach that no one ever took and leads immediately to disaster. You
Right.
wonder why are we even bothering to rule it out? It didn't do us much good, and it's kind of, as you point out, internally incoherent in
Right.
various ways.
Right.
It doesn't seem like we should have to go to such great lengths to say, don't do that. There doesn't seem to be much recommend doing it, right?
That sounds
So then
fine.
you say, well, what do we do? Well, I don't know. First of all, we don't form a hell of a lot of opinions at all before we open our eyes. We open our eyes, we trust our memories. We think because we trust our memories, we acquire various information about how the world works.
Right.
We assume that the early world worked pretty much the way the present world does. We notice the present world has a hell of a lot of there being a stiff entropy gradient for all this stuff going on.
Right.
Star formation. So we figured, okay, the early universe, so that means the entropy gradient had to be pretty stiff going all the way back.
Right.
That's going to get us to a low entropy, you know,
I mean,
to a low entropy thing. It just
Right.
doesn't sound so fancy if you put it that way, but what's wrong with putting it that way?
I don't think there's much wrong with putting it that way at all, except that it does leave one interesting thing out. Okay. And that is that that there's a funny way in which these, in one sense, directly observational claims about the early states of the universe sort of bootstrap themselves, okay, and everything
Right,
else.
as you say, you want the scientific theory you produce by these means at the end to validate the reliability of the
Right.
means by which you came. So
That's
there's
right.
that closing of the circle.
Exactly.
If the circle doesn't close, then you get into this
Exactly.
unstable state you're worried about.
Exactly.
And we all agree that's a bad state.
Exactly right.
Okay.
That's
That's the normal stuff. What we find, you don't get into that.
I
So you
agree.
don't really need a transcendental argument.
No,
Notice everything closes out.
and that's what I've been saying for the
Yeah, yeah.
past 15 minutes.
I
Yes.
agree.
I agree.
The rhetoric shifts around
I
and makes
agree.
something sound much more grand and something less grand.
Well, it sounds more grand or less grand depending on how you come at it, okay? You could come at it by saying, what are our normal observational protocols lead us to say
Right.
about the early state of the universe? It's that. But then here's an interesting thing to ask. You could come at the whole business from a different angle. You could say, what is it that we learn about the world from science, which validates our procedures of trusting our memory? Hey, look, it's the same thing.
Right.
Okay, that's the structure of it. Yeah.
Okay. Getting a bit puzzled about some of the directions, going back to Shelley's dinosaur concerns. I can imagine having this conversation with paleontologists, and they say, what the hell are you talking about? We've got a lot of very reliably confirmed high-level scientific results about erosion and all this stuff, and all that tells us that, look, it's these laws are highly tiny, symmetry,
Right.
and blah, blah, blah. And, you could say, well, look, you're not using the fundamental laws, that's what should happen. But they're going to say, well, hang on a second. What makes you think these fundamental laws are right? Why is my evidence for erosion less valuable than your evidence for Higgs boson?
Yeah.
And you're going to say various things, but one of the obvious things you're going to say is, look, I can derive your laws, ceteris paribus, from my laws. And they say, well, just from your laws? And you say, well, from your laws, from my laws plus the past hypothesis.
Yeah.
So
Well,
in
that's
that
part of
case-
the laws, I think.
Right, so in that case, even to get the game off the ground that says there's a coherent epistemic starting point where we have the law of physics, it seems we also have to have a past hypothesis, because without that, we don't have the bridge that lets us annex all of that evidence for the higher special sciences, on your story, into our evidence for fundamental laws.
I think I agree with that, but let's see. Here's what I don't want to be in the position of saying. I don't want to be in the position of saying that there's something methodologically wrong with the procedure of opening your eyes and, until you get evidence to the contrary, trusting in what they report to you. Okay? It's a question that comes up later. How does all this fit together? How do all our scientific beliefs about the world and our procedures for investigation all comprehensively fit together? Okay? But that's a question later down the road. Surely it would be crazy to say that someone ought not proceed by trusting their eyes until they have this whole scientific argument.
Right, sure. When you open your eyes, simply opening your eyes, unless you happen to be looking at the aforementioned T-shirt, won't tell you it's physics.
Right. No, that's true. No.
So I guess
Okay, right.
what I'm questioning is the epistemic position that says I know basically nothing except the microdynamics.
Right.
And I can see a situation that says I know a whole bunch of laws,
Right.
various kinds of various domains.
Good.
The ability to unify them on your program itself depends on past hypothesis.
Good. I agree with that. Yeah, Alice.
I just want to check the exact reasons that we get to go all the way back to the past hypothesis, rather than whatever state is required to get all the measurement results we currently have.
Right.
It's kosher. I mean, at one point you mentioned, I think, conservatism of some sort.
But wait, what makes you think those two are different? That is, we have things, we have, say, paleontological evidence that assumes a ready state of the clay into which the bones fell before the bones themselves started to disintegrate. And we have astronomical evidence.
But I assume there are some parts of the universe we have not observed yet. Would that be fair?
Yeah, that sounds right.
Okay.
Yes.
So it's concerning those bits.
Right.
I mean, so given the procedure so far, we don't want to stop just at the point which has the laboratory condition required to generate just the things we happen to observe.
Right.
We want something sort of further back than that.
Yes.
At one point we had something about, I'm not sure if conservatism came in here, certainly simplicity seemed to come in with
Right.
the Diamond book.
Right.
Tim, think you're suggesting a different kind of conservatism, like the sort of regularity we observe around this time period should be sort of kept constant?
Right.
Is there a specific, explicit proposal for what we want here? Or?
Well, I take it we want something that's going to underwrite all of the kinds of extensions that we can easily anticipate of our current methodological protocols. Okay? So yes, there are parts of the universe that we haven't observed yet. Okay? Maybe there are times farther back than we've observed yet, or something like that. But we're going to want it to be the case unless there's explicit reason that comes up to believe otherwise. That what counts as evidence about times this far, that things that are structurally similar in the appropriate way to what counts as evidence for times this far back is also going to turn out later in our investigations to count as evidence for what's this far back, and so on and so forth. I don't know, or maybe I'm misunderstanding your concern somehow.
That covers most of it. So there's something about similarity in what would underwrite the measurements.
Yeah, I would think so.
Measurements.
Yeah. And also, as you said, simplicity, and so on. Here, put it right at the beginning, okay? The whole thing, both the measurements we've done so far and our anticipation of future measurements and so on and so forth snaps into place, just like that, okay? What more could you want?
Of course, what's the evidence for the Big Bang and everything? One doesn't really have to, from a scientific point of view, too much address this question.
No, but there's a sense in which on investigation it's taking that further. That's the funny thing. As you get further and further back, it kind of bootstraps itself. Okay, you have this normal observational evidence for it. Okay, and then you ask, what is it about the way the world is that justifies our usual procedures for putting faith in our normal observational evidence? And those two lines of thought tend to converge here.
Mm-hmm.
That's the claim.
Sure.
That's the claim. Yeah.
Okay, I just want to be sure I understand what you're doing here and why you brought
Me
it
too.
So say that we didn't have the past hypothesis and I have a fluctuation, and I wouldn't be able to trust my memories.
Well, let's see. You didn't have the past hypothesis, and as Tim correctly said, you start out with this prior that nobody in his right mind would actually start out with. But you start out with, that's right. So you don't have the past hypothesis, you start out with this prior, then you're stuck in one of these years.
Right. And so then I'm not able to trust my memories, and I have no special epistemic access to the past anymore than the future, because my memories would be just as likely to be memories of the future as the past, and more likely just crap.
Mm-hmm.
So bringing in the past hypothesis along with the dynamics allows me to accounts for my having accurate memories of the past and no memories at all of the future. So you brought in the idea of inference by measurement to make the claim that the past hypothesis lets us treat our brains and the world more generally as measurement devices.
Yeah.
Correct?
Yes, that's right. That's exactly right. That's exactly right. I mean, just we've been on a long sidetrack here, but maybe a necessary one. But yeah, the deal is good. Why is it that that we have this kind of access by means of inference by measurement only toward the past and not toward the future? Proposed answer, because toward the past, okay, there's a natural place already there in the laws for the regress of ready states and early ready states and early ready states and early ready states to terminate. Okay, and there's no analogous place for them to terminate toward the future. Okay, there's nothing of that kind that we have the right to help ourselves to as an assumption about the shape of the future. Okay, and the claim is that's what's at the bottom of the asymmetry in our epistemic axis.
Assume that this gives us a time asymmetry in inference by measurement.
Yes.
It's still the case that most of our, or a good chunk of our knowledge of the past is not inferential at all. Like, it's not like I'm, taking my the current state of my memory, taking the state of my memory 5 minutes ago, and then perform an inference.
Oh, no, well, I don't, it's certainly not of conscious inference. I don't think that,
Well, it's not even clear that there's some kind of subconscious inference thing here.
Well, I'm not, I mean...
What makes it the case that I have knowledge by memory is just the fact that my memory is a reliable tracker of...
No, but so put it differently.
There's no need for performing an inference.
Maybe the use of the word inference is very misleading. Here's a different form that the question could take, which I take it is answered by the past hypothesis. It's a feature of the world, okay, that there are sort of, that there are correlations of a certain kind, okay, between various present physical features of the world, okay, and features in the past, okay, that don't obtain between present physical features of the world and features of the future, okay? I think the easiest way to describe these correlations is that they're correlations that arise as a result of these measurement type situations. But that's not supposed to refer to any actual inference that's going on, okay? It's just the kinds of correlations that are imposed between present states of the world and past states, given that is once you conditionalize on a certain other thing having been true of the past, okay? It's the kind of correlations that are snapped into place by conditionalization on something like this from another time, okay? And the claim is that whether it involves any inference or not, conscious or unconscious, those kinds of correlations, okay, the possibility of those kinds of correlations depends on the past hypothesis. And the reason that they're absent toward the future, okay, those kinds of reliable correlations, okay, the reason that they're absent toward the future is because of the absence of an analogous future hypothesis. So, yes, if inference is if the word inference, and maybe it is being misleading by conjuring up pictures of conscious calculation or something like that, that's certainly no part of what's going on here, and it's not proper in other. I agree with you that it's not appropriate in other kinds of contexts to describe me relying on ordinary memories of mine as cases of doing an inference. Okay. I just mean it turns out that the structure of the kind of correlations you're talking about, okay, is easy to model, okay, by talking about what kinds of correlations would be imposed by imposing this kind of condition on the past here, by conditionalizing on this kind of thing in the past here. So it's easy to model those as the upshots of certain kinds of inference is. But that's certainly not intended as some kind of a naturalistic description of what's going on in those cases. But if the question is, do I also think that this, that this is what lies at the bottom of our having mnemonic access to the past and not the future? Yes, very much so. Very much so. Yeah. Yeah.
I'm worried that time asymmetry of all processes in the present world are explained by the past hypothesis. So I'm thinking
You're
about,
worried that everything is explained?
Yeah, so
What,
I'm thinking about
isn't that good?
I'm thinking about an example of nuclear decay.
Yeah.
For example, a neutron into three parts.
Oh no, the time asymmetry of weak interactions, for example. No. That's we're not talking about that here. That's a separate thing. Nobody has. So yeah, there's good reason to believe that there's violations of time asymmetry in the dynamics itself.
Time
Okay.
symmetry.
Time symmetry, excuse me. But nobody, as far as I know, has ever succeeded in making some kind of an argument that those asymmetries can account for things like the thermodynamic asymmetry, the asymmetry of epistemic access.
You're saying that past hypothesis has no implications?
No, it has no implications about
So
this.
how do you solve these symmetries in fundamental thoughts then? Given the
Wait,
asymmetries of these physical
I'm sorry, I lost you.
When a particle decays into three particles.
Right.
And you imagine the time reverse process where all three of them come together. It seems
Right.
less likely that all three would collide at the same time.
No, that's an ordinary statistical mechanical asymmetry. I take it that's not what he's talking about. What he's talking about is the fact that there are genuine time asymmetries in the fundamental dynamical laws of weak interactions. Okay? The unlikelihood of three particles coming together at the same time is just a manifestation of the ordinary
I
statistical.
think he's
Why
worried
is-
about
why
whether
is
the
that
past
not-
hypothesis explains that.
Yeah.
Oh,
I was thinking
yeah.
about that.
Oh, yeah. Oh, but yes, that the past hypothesis.
And why does that not explain the asymmetry of weak interaction?
Because the asymmetry of weak interactions is traceable not just to that, it's traceable to a term in the interaction Hamiltonian itself that's not invariant under time reversal. Okay. It's not entirely traceable to the likelihood or unlikelihood of three particles coming together. There is, if you write down the Hamiltonian that governs weak interactions, if you write down the Lagrangian that governs the weak interactions, there's a term in it that's just simply not invariant under time reversal. Okay? And that, these statistical mechanical considerations have nothing to do with. Right.
That question over there, though, was related to the causal arrow of time, which probably you didn't get to yet.
Right, so which question was related? There are several directions from which you could approach it. Here I take it as the easiest one, given the way we've set things up so far. So, go back to the billiard ball case. We've got these billiard balls. I don't know what. Say we know. Well, we've got these billiard balls, and as a sort of toy stand-in in this example for the past hypothesis, we're going to help ourselves also to the information that, say, billiard ball number 5 was moving 10 minutes ago. Okay? Good. And what we noticed on the epistemic side of the equation was that given the information that billiard ball number 5 was moving 10 minutes ago, whether or not billiard ball number 5 was involved in a collision over the next 10 minutes can be settled, at least settled in the affirmative, okay, simply by the observation that billiard ball number 5 is stationary now. Okay? Completely independent of any information we may or may not have about whether any of the other billiard balls on the table are currently doing. Okay? On the other hand, given no information about the situation of billiard ball number 5 at any time in the future, okay, the business of predicting whether or not billiard ball number 5 will be involved in a collision over the next 10 minutes is going to involve complicated calculations, and it was going to involve as input information about the positions and velocities of all the other billiard balls on the table. Note, as we said before, that as the number of billiard balls on the table rises, the amount of such information that you have to input and the complexity of the calculation you have to do rises along with it, whereas increasing the number of billiard balls on the table has no effect whatsoever on the complexity of the inference you need to do in order to decide whether or not billiard ball number 5 was involved in a collision over the last 10 minutes if you have this piece of information about the past. Yes?
Are you asking whether billiard ball number 5 will be moving in 10 minutes, or are you asking?
No, I'm asking, well, just as I was asking about the past, whether it will be involved in a collision over the last 10 minutes.
Then you might not need to specify a completely precise initial condition.
No, you might not. You might not. But the amount, that's absolutely right. But the amount that you're going to need to specify is going to rise as the number of billiard balls. You're absolutely right. Yeah, you could certainly get away with less than a precise.
If you're asking a narrow question, then
yes,
you don't need.
That's absolutely right. That's absolutely correct. But still, as the number of balls rises, it's going to dwarf the amount of information you need to make the inference toward the past. Okay? Okay. Look at exactly that from the flip side, by which I mean as follows. Suppose we ask a question, a sort of counterfactual question, of the form, what differences in the present state of the billiard balls, okay, would make a difference to the question of whether or not billiard ball number 5 will be involved in a collision over the next 10 minutes? Answer, many. Okay? There might be things you could do to billiard ball number 17, okay, changing its position or changing its velocity, that would change the facts about whether or not billiard ball number 5 will be involved in a collision over the next 10 minutes. Or there are other things you could do to billiard ball number 24, okay? Or there are still other things you could do to billiard ball number 47. Everybody with me here? Okay? There are imaginable changes in the state of any one or any combination of those billiard balls, all of which might very well change the facts counterfactually about whether or not billiard ball number 5 is to be involved in a collision over the next 10 minutes. Okay? There are, you might say, an enormous a wealth and variety of what you might call causal handles on the future collision history of billiard ball number 5 in these various billiard balls. If you could get your hands on almost any one of them and do with it what you liked, okay, you could very likely change the facts about whether billiard ball number 5 is to be involved in a collision over the next 10 minutes. Either by putting the billiard ball that's under your control on a course to knock into billiard ball number 5, if billiard ball number 5 is not to be involved in a collision in the present state of the world, or by putting it on a course to knock a billiard ball that was on course to collide with billiard ball number 5 off course, so as to prevent a collision that otherwise was going to happen, or something like that. The flip side of what we've just observed, okay, is that given this past hypothesis, okay, the only thing you would, the thing you would need to change, and the only thing whose changing would make any difference to questions of whether or not billiard ball number 5 was involved in a collision over the past 10 minutes is the state of billiard ball number 5 itself. Okay? That is, the available causal handles to the past collision history of billiard ball number 5 are very sparse and very rare. Indeed, here, there's only one. Okay.
There's only 0. I mean, In your analogy, you alter the other billiard balls to future things by moving them.
No,
Yes. Well,
No.
what do you mean?
I
What do you
mean,
mean they're under your control?
I-
Suppose billiard ball 5's motion right now is under my control. I have my fingers on it.
no,
Still
So
nothing
that's
I
not
do will
what-
change whether
no.
it collided 10 minutes ago.
it's just wrong.
The point is the motion of billiard ball 5
Yeah,
is indicative of what happened in the past,
yeah.
only under the condition you didn't touch it.
And nobody's talking about touching it. I'm talking about entertaining
Then why are
counter.
these causal hands?
I'm not, so,
What do they have to do with causation?
it has plenty to do with causation. But maybe if one takes the word handle too literally, it can be misleading, okay? What we're doing at the moment is playing a game of entertaining counterfactuals. The counterfactuals aren't I come in and move these billiard balls around, okay? The antecedents of the counterfactuals of the form are of the form, these billiard balls have various different positions and velocities at present, okay? That's the deal, okay? And so here's the observation, okay? If you imagine being given a situation where the positions and velocities of various of the other balls on the table are different than they actually are, that would give rise to different counterfactual claims, okay, about whether or not billiard ball number 5 is to be involved in a collision over the next 5 minutes, okay? On the other hand, no such changes, no such different counterfactual antecedents, other than ones that refer to the position or velocity, or I guess the velocity of billiard ball number 5 itself, okay, would result in different claims about whether billiard ball number 5 was involved in a collision over the past 10 minutes, okay? That's all I'm concerned to establish now, okay? So that there is a way in which, okay, the past collision history of billiard ball number 5 is radically less sensitive to these counterfactual changes in the present state of the collection of billiard balls than its future collision history. Yeah?
I have a really annoying question. Isn't it true that billiard ball number 5 could be fooling you?
Could be fooling me.
You could say, okay, look, I can devise a collision history for billiard ball number 5 such that it appears to, such that, it has the same velocity and is in, that it did 10 minutes ago, and is in the position that it would be as if it had.
Oh, yeah. No.
So
Of
there are
course
other
that's
possible
possible.
handles.
No. I was a little more careful than that. Maybe I said it under my breath, although I think I said it. The only way the collision history can be resolved by the present state of billiard ball number 5 is in the affirmative, not in the negative. Okay? If its current velocity isn't what its velocity was 10 minutes ago, then it was involved in a collision. It might have been involved in more than one collision, but it was involved in at least one collision. Okay? And of course, the way to make these examples richer, okay, the way to distinguish between its being involved in one collision or more than one collision or so on and so forth is to populate this world more richly, okay, with different objects that interact with this billiard ball in different ways and with different time dependencies. And the more of that you have, the richer and more detailed a picture of the past of billiard ball number 5 you'll paint, okay, by seeing it there. I'm just looking here for the simplest and most primitive imaginable example. Yeah.
So, when you say there's just a single adjustment we need to make, which is what's going on with billiard ball number 5?
Well, I don't want to, because it led to misunderstandings of Tim's, maybe that's a bad way to put it.
Okay, so
A single counterfactual, change.
counterfactual scenario.
Right.
But it seems like the counterfactual scenario can differ only with respect to what's true of billiard ball number 5. That can't be one that changes only what's happened to billiard ball number 5. You presumably also need to change what's happened to some other billiard ball game.
Oh yes. Oh no. That'll impose changes on. I'm just talking about what you need in order to reliably make the inference. Okay. If billiard ball number 5 was moving and it's now stationary. It wasn't involved in a collision. Okay? In another situation, a counterfactual situation, in which what you happen to know is that billiard ball number 5 was moving and, what do we want to do? Yeah, we need a little more detail. And is now moving in the same way. We can't make the inference anymore that it was involved in a collision.
Okay, so I thought this was now about the number of causal handles, or, you know, putting aside whether or not that's a worrisome label.
Right.
I think this was now about the number of causal handles that we have on altering
Yes.
what happens in the future
Yes.
and what's happened in the past.
Yes.
It seems that there are precisely as many respects in which there are differences, counterfactually different prisms.
No. No, so let's see. No, I guess, no. There are, here's the situation, okay. Suppose that the billiard ball was previously stationary and excuse me, the billiard ball was previously moving and is now at rest, okay? One wants to say, independent of the conditions of the other billiard balls, it couldn't have been involved in a collision. But you're pointing out rightly that that's not literally true, okay? Because suppose, suppose the following were the case, okay? It's stationary now, excuse me, it was moving earlier, it's stationary now, okay? But you evolve these other billiard balls backward in time. I don't even know how to do this. There are certain arrangements of the present state of the billiard balls, together with the claim that billiard ball number 5 was moving 10 minutes ago, which are just violations of the dynamical laws. Okay? But those are quite complicated states of the whole collection of billiard balls. But you're absolutely right about that. Yes, there will be certain. That is, there will be, take a state of all the billiard balls at present, okay, which determines by microscopic retrodiction that there was no collision, okay, and suppose that the state of the billiard balls at present, which determines by microscopic retrodiction that there was no collision, involves billiard ball number 5 being stationary, and I suppose I add to that billiard ball number 5 was moving 10 minutes ago. That'll simply contradict the microscopic equations of motion. Okay? That I can't do. Okay? So yes, these two things will put very complicated constraints, okay, on the collective state of the rest of the billiard balls. Okay? The more such billiard balls there are, the more and more minimal those constraints become on each billiard ball individually, or even on relatively small subsets of those billiard balls. But yes, it will impose as a matter of logic a constraint on the total state of the whole rest of the collection of billiard balls. That's true.
Is the asymmetry between past and future in this case kind of parasitic on the differential asymmetry, the epistemic asymmetry, as far as that affects the kind of constraints we can put on?
I'm sorry, say it one more time?
Sorry, so just in terms of, I think slightly lost where the asymmetry between past and future is it in some sense kind of parasitic on the epistemic asymmetry insofar as...
It's going to, I don't know if parasitic, I guess I'm willing to accept the word. Yeah, it's parasitic on the epistemic asymmetry.
Right.
That is, what you learn from the epistemic asymmetry, okay, is if this were different, okay, excuse me, if what you learn from the epistemic asymmetry about the counterfactuals, okay, is something like this. There's no simple way for any of these or any subset of these to be different, okay, in such a way that given that this and this are the same, okay, in such a way as to make a difference as to whether this was involved in a collision, okay, in the past, okay. There are millions of simple ways for small subsets of these to be different, okay, such that they would make a difference toward the future as to whether or not the thing is to be in a collision,
But that's part because we're not allowed to help ourselves information about what's going on political and applied.
In the future, that's right. That's exactly right. That's exactly right. It's because we're not allowed to help ourselves to information like that there are lots of ways these could be different so as to affect the future collision history. There are very few ways these could be different so as to affect the past collision history. Okay? Now, if you want to, I mean, this is perhaps a longer story than I have a chance to tell here, but let me say a little bit. So that's what one means. Maybe handles is a bad word. Okay, that's to a first approximation what I'm trying to convey by saying something like the present is sort of strewn in all directions with causal handles on the future. Not so with causal handles on the past. Causal handles shouldn't be construed as something you could grab with your hand and thereby affect the future. How should it be construed? Well, what do you need to do in order to ask questions in the context of a deterministic theory like classical mechanics, say, about what we could do, what we could affect, what it's within our power to do, blah, blah, blah. That is, on the face of it, there's some kind of tension, at least naively, between all this kind of talk about agency and the claim that the theory is deterministic and that everything that was going to happen was determined, billions of years before any of the agents were born, and so on and so forth. What kind of game do you need to play in order to make sense, in order to even to begin to make sense of questions of the form, what can we affect and what can we not affect, okay, in the context of such a theory? Well, there are lots of ways to play such games. Alison Fernandez, who's here, is doing work that plays those games in a much, much more sophisticated way than I'm going to outline here. But it's a way of getting a beginning of a handle on what you might do. You could, as a first approximation, adopt the following fiction of agency. Okay? Imagine the following fiction. Okay? That the way you get to exercise your agency, that is, imagine the following fiction. The content of the fiction is that there are certain features of the world, okay, a very limited set of features. Maybe the positions of your fingers, or better, the electrical currents in your motor neurons, or better than that, the states of certain tiny parts of your brain, or something like that. There are certain features of the current physical state of the world, some very small set of features of the current physical state of the world, over which the content of the fantasy is you have what you might call direct and unmediated control. Okay? That is, you don't affect these things by pushing them around with any other physical object. Okay? You just directly choose their values, okay, at a certain particular time. Okay? And then the question of what you can affect and what you can't affect comes down to the question of what the stuff that you have this kind of direct and unmediated control over can be parlayed into in terms of control of more remote things by means of the laws of physics. Okay? Everybody understand what the rules of the game are? Okay? Like I say, there's plenty to say along the lines of one wants a much better and richer representation of agency than this in order to really discuss these problems well. But here's a way to begin to discuss them. So you have this fantasy of there being some very small set of the present physical features of the world of which you have this kind of direct and unmediated control. This control, this refers back to what Tim said, is absolutely not by means of pushing them with your hand or something like that, okay? Otherwise, like he said, everything gets wrecked. You get these sort of screening effects that make nothing relevant at all. Okay? So the fantasy is that there's a certain moment at which you get to choose the values of these certain particular parameters. Because the theory is deterministic, that's of course equivalent to choosing among different entire trajectories of the history of the world. Okay? The claim is that if this kind of structure that we've seen here scales up in the appropriate way, as we look at much, much richer pictures of the world, the deal is that if it happens to be the case, if you ask about affecting the future history of the collisions of this ball, if the thing over which you have direct and unmediated control is almost any one of these billiard balls, okay, you're probably in pretty good shape. If these billiard balls are close enough together, if they interact richly enough, so on and so forth, there will be counterfactual changes in almost any one of them, okay, that could in principle be capable of affecting the future collision history of billiard ball number 5. If you want to affect the past collision history of billiard ball number 5, you're out of luck, unless the thing over which you have direct and unmediated control just happens by luck to be billiard ball number 5 itself.
David,
Yeah.
let me make, there's an incoherence. It's not a question of the fantasy. There's an incoherence in what the significance of the motion of billiard ball 5
Right.
in your original observation
Right.
was information.
Right.
Its state of motion could be a reliable signal, a reliable indicator of what happened to it in the past.
Right.
It only is such an indicator if you don't have, if its motion is not a consequence of your choice.
It's not a
If
consequence.
its motion is somehow directly, indirectly,
No.
or whatever, to be ascribed to your choice,
Yeah.
its value as a signal
Yes.
disappears.
Yes.
On the other hand, with respect to the future, nothing like that matters. Suppose you say, what if billiard ball 7 were moving? Why is it moving? Because I just pushed it. Fine,
Right.
I don't care that you just pushed it.
Right.
Still, the collisions will go on.
Yeah, Tim, you're misunderstanding here. Look, you're not supposed to think of my choosing the state of billiard ball number 5 as analogous to my in any way deciding to push it around. You're supposed to think of it as a choice you're supposed to think of the exercise of this fiction of agency as a choice as to which world I'm living in, okay? Am I living in the world, okay, past and future, okay? Here's the question. What my agency does at the moment when it operates, one shouldn't even say at the moment when it operates, because that's not coherent.
That's right.
Okay? I'm choosing whether the world I'm in, okay, is the world where billiard ball number 5 was stationary, or the world where billiard ball number 5 was moving, okay? In the world where billiard ball number 5 was moving, okay, and nobody did anything, okay? In the world where billiard ball number 5 was moving, okay, it was involved in a collision, or I forget how it goes here. In the world where billiard ball number 5 was stationary, it was involved in a collision, okay? In the world where it's moving, it wasn't necessary.
Look, there's a big deal you're making here about toward the future and toward the past.
Yes.
If the fiction is, I choose an entirely fully realized world, that's what I choose.
Yeah.
That choice doesn't happen in any time, there's nothing to the future or the past of that choice.
No, but it's the
There are lots of changes there to do.
wait. It's not, yes, it's not a physical event that occurs in accord with the laws. That's why, once again, there are much better ways of telling this story, such as ways that Allison is working. I can't begin to get into more satisfactory ways of telling the story here, but the deal is something like this, okay? You conceive of the action of your agency, okay? Conceive of it directly if you want, as making a choice, okay, about what value of this variable obtains at this time. Given the deterministic laws of physics, okay, that's equivalent via the operation of those laws to choosing an entire trajectory.
Right.
Okay? But if you want to specify the terms of the choice, if you want to make it sound more like an event that occurs at a particular time, okay, think of it as a matter of choosing the value of this variable at this time. Okay? Then, okay, what you conceive of your agency as having the power to choose is between the history of the world that has the feature that this has this variable at this time, and the other stuff is the same, and the world that has the feature that this variable has some other value at this time. Okay? Here's the proposal for evaluating what we can influence. Okay? You may want to disagree with this proposal as a way of capturing, and indeed I would disagree with many aspects of this proposal. It's way too simple as a way of capturing capturing our talk about what it is we can have influence over, or what it is we can have control over. But the most primitive version of it is, okay, you think of yourself as just being able to choose, not to manipulate, not to push, okay, to do some non-physical thing, which is choosing, okay, the value of some very small and restricted number of physical parameters at a certain time. And then you see what effects that has by seeing which physically possible history of the world that lands you in, okay? And if you evaluate it like that, it becomes very transparent, okay, why there are many more opportunities for us to influence, in this sense, the future than there are for us to influence the past. Of something like billiard ball number 5.
And then I'll stop. You say, don't use the word handle.
Right.
Really good idea, because it's like you say, it's like catch-22. Here's a handle. If it's down, X and X will happen. But oh, if you pull it down, it won't.
Right.
It's a handle that works just in case you don't pull it. Now, what we actually do when we deliberate is we do evaluate subjunctive conditionals, which are very close to counterfactuals. And those subjunctive conditionals do involve our pulling things and pushing things and moving them around and so on. And we try and figure out what would follow under these subjunctive conditionals, given the laws of physics, of those conditions so described.
Tim.
We do not fantasize ourselves out of existence in this way. So the question is, why do these there are these counterfactuals.
Right.
They have obvious things to do with information theory, which is what you started with.
Right.
We understand why the motion of the ball is a good signal,
right,
an indicator of its earlier,
right,
and to what extent its present motion is a good indicator of its information. That is
right,
the future.
Right.
All of that is very clear.
Right.
When you add actual control that you're controlling,
right,
it destroys those information theoretic connections.
So
and
Tim,
you're trying to do something that doesn't fit together.
Okay, so here are the motivations for this.
Excuse me, can you explain why that happens? Exactly.
Sure, because look, what David said correctly is, I know the ball was not moving 10 minutes ago. If I look at the ball now, and I know I didn't touch the ball, okay? The only other thing that ever came into contact with the balls, if anything, were other billiard balls. And it's now moving. I can infer some other billiard ball ran into it. If I can control the billiard ball's present motion, right, if it could be moving now because I chose for it to move now, then its present motion is no longer an indicator of anything about whether it previously provided billiard balls. It's an indicator of what I chose to do with it.
Right. Now, here's the story. A more full-blooded, psychologically faithful, or not even psychologically faithful, metaphysically faithful account of agency, okay, is going to involve processes like deliberation, like you said, so on and so forth. That is, it's going to involve a whole lot with at least as it's usually conceived, a time-directedness already built into it. Okay? The exercise here is to try and come up with some model of the fiction of agency. Okay? first of all, because it's instantaneous, has no time directionality built into it. That is, here's what we want to see. It might be the case that the time directedness of what we're able to influence might just be a consequence of the time directedness of things like deliberation. Okay, all sorts of time directednesses which are already built into our ordinary conception of agency. Okay, and don't have much to do with the time directedness, for example, that we get from the past hypothesis that's imposed on the world by the past hypothesis. Or it might be the case that the time directedness of our capacity to influence things is very directly related to the time directedness imposed on the world by the past hypothesis, in much the same way that the time directedness of thermodynamics is, and the time directedness of the asymmetry of epistemic access is, and so on and so forth. One of the reasons for coming up with such a highly artificial version of the fiction of agency here, okay, is to make sure that by making use of this fiction, we're not introducing any additional time directednesses into the world associated with agency itself, so as to be able to diagnose more clearly what the actual source of the asymmetry of influence is. Okay, whether it's something that we can blame on the past hypothesis, or whether rather we ought to look for it in time directednesses associated with the notion of agency itself, and so on and so forth. That's among the reasons why one is taking such pains to develop such a highly artificial version of a fiction of agency here. Because one wants to, in order to investigate the suspicion that it's really all coming from the past hypothesis, one wants to make certain not to introduce any additional time asymmetries. Time asymmetries which would be introduced by deliberation, by notions of pushing of the kind you're talking about, and so on and so forth, because those, as you say, will screen off the past, not the future. We want to, the exercise here, the initial exercise here, is to show that the familiar time asymmetries of control emerge even in cases where you have taken pains to eliminate the possibility that a time asymmetry has been introduced from any other source. That's the point of formulating it this way. That's the point of formulating it this way. Does that result in a crazily artificial form of the fiction of agency? Absolutely. Okay. Once we've been through this, we're going to want to become much more realistic about what the structure of the fiction of agency is, and take that where it leads. But the usefulness of exercises like this is to be able to pinpoint the diagnosis of where the asymmetry is coming from, in order to bolster an argument that the source of this asymmetry, just like all the others, is the past hypothesis. That's why it's being done this way. That's why it's being done this way. Good. Yeah, David.
Just a question about the kind of way of setting this kind of thing up, that I'm not quite sure about. So, in understanding things like agency and influence, the kind of physics that seems to govern the scales on which agency and influence happen, or kind of science, but including the kind of physics, is all governed by a bunch of equations which have a massive amount of time asymmetry in them. Now, that's true.
I mean, which have on the phenomenological level.
Yeah, but I mean, the kind of laws that we're using to support counterfactuals, those laws are, the kinds discovered in social sciences, the kinds discovered in how they're all quite manifestly asymmetric in time. Now, yeah, it's true that we think we've got a story to tell that explains how they can be high-level immersion from basically time symmetry underpinning.
Right.
It's true that process involves the past hypothesis, but my kind of thought is, having already committed to the past hypothesis to get out the validity of those time asymmetric macro laws, I mean, at that point it seems entirely legit to help yourself to all of those time asymmetric laws in understanding why.
No, but I don't understand. There are actually people around, like maybe sometimes U Price, although U is very, very often difficult to pin down on, okay, who think things like the place to look for the asymmetry of causal influence is in the asymmetry that's implicit in our very conception of agency, is the time-directedness that's implicit in our very conception of agency. Now, Hugh is a little waffly. Hugh says, now maybe this time-directedness of agency could itself be derived from more fundamental time-directednesses that you could get from the past hypothesis, but maybe not, okay? So it's at the end of the day not clear what the relationship is between the directedness of control and the directedness and the directedness that we get from the past hypothesis.
Yeah.
What this kind of fiction of agency is laboring to help make clear is that the relationship is very tight.
Okay, so I'm not disputing, well, for the sake of argument, let's stipulate, I'm not disputing the fact that one wants a framework that takes out the asymmetry of agency for the story.
Good.
But what I don't see take out is the asymmetry of the various analytical laws governing the things which are influence.
Well, but so what do those get us? I don't understand. Is there going to be some? This is just a question to which I don't know the answer. Is there going to be some simple line of argument from the asymmetry of, say, I don't know what the relevant laws are, chemical interactions or something like this, the asymmetry of what you're calling the relevant emergent laws, to an asymmetry of influence?
Actually, now I just think about strategy. I mean, here's the thought. Let's
Right.
we lived in a world where all of the fundamental laws
Right.
were just thick with time asymmetry of all of the
Right.
kinds.
Right.
And then
Then you wouldn't be astonished.
well, then somebody says, suppose, why is it we can influence the past
Yeah.
and the future? We can understand, there might be questions of detail to fill in, but it's really unmysterious because there's a
But
massive
look-
asymmetry built into the physics.
Let-
So if we have an emergent understanding of why that is at the levels of interest, that doesn't seem obvious.
Let me give a reason for thinking otherwise. Not a decisive reason, but let me give a reason for thinking otherwise. I take it, okay, that if we were to meet Martians or Alpha Centaurians, there are all kinds of differences between them and us, which we would find unsurprising, okay? They have very different physiological structures, okay? If the kinds of foods that taste good and bad to them are very different from the kinds of foods that taste good and bad to us, we're not going to be surprised. Probably if their moral intuitions are very different from ours, we're not going to be surprised, so on and so forth. If their their time asymmetry of control is inverted with respect to ours, I think we would be astounded, okay? And I take it that constitutes prima facie reason to believe that the place to look for those time asymmetries is at a much deeper and more general level than the level of sort of special sciences that apply to the physiology of human beings or something like that.
But my worry is often we've already got, if we buy the story you've told us, or if we buy any of the other various ways we might understand these things, we've already got the fact that, however parochial a given special science laws are, these kind of laws are all aligned in the same direction in an appropriate way. So there's not a problem of universality here.
Okay, suppose I grant that, but I'm still puzzled. Why would the question is, it's not, you're right, if the world were rife with time asymmetries, maybe we wouldn't be surprised to find out that there's an addition of time asymmetry of causal influence, okay? But we'd still want to know in more detail, how exactly does that work? How do the existing asymmetries? This is an attempt to link that asymmetry directly with the ones that exist on the most
I guess if you like, take this as an observation rather than objection.
Right.
You've already told a story that takes us from certain fundamental starting points to a dynamical asymmetry in macro laws.
Right.
There's another story which also starts like that starting point takes us to asymmetry. Fair enough. I'm just saying there's no need to think it has to go that way. It would be entirely legit to decide to use some big stuff.
That's fair enough. Good. Should I say one more thing? I don't know if I should say one more thing or not.
David, how much is the story you're telling now about causal asymmetry? How far does it go beyond the story you told before?
You mean about epistemic asymmetry?
Yeah, I mean, once
It's very closely related.
if you have records, if you have things of which you have records
Right.
of the past, by the very nature that means that are going to be robust to all kinds of change.
Yes, absolutely.
And that's-
No, that's right. No, it's very closely related. I mean, here's another way to put it. Okay. Here's another way to put it. Here's the present state of the world. It's littered with all these records of all kinds of stuff. Okay? And those records, for reasons we've explained, are records only of the past, not of the future. You consider now the sensitivity of a world strewn with records like this, to small changes in some little variable here. Okay? The intuition is that although this can splay out wildly towards the future, the existence of these records, as it were, exerts, just figuratively speaking, a very strong pressure that shoves these trajectories together toward the past. Okay? Even if there are little variations here corresponding to the position of your finger or the level of electrical excitation in your brain or something like that, it's exactly as you said. What we've learned about the epistemic asymmetry can be conceived of as exerting a sort of pressure that shoves these trajectories together toward the past, which is absent toward the future. Yeah, so I agree, it's very closely related. I mean, maybe there's one other thing to say about the relation, and then I'll stop or collapse or something like that. That will also involve my stop. So, last little observation. This second consequence, this second difference that I mentioned between inference by measurement and inference by prediction, that is, the second observation was something like this. It's a special feature of my epistemic relation to the past that doesn't have any parallel in my epistemic relation to the future. That I can know things, say, about the position 10 minutes ago of a billiard ball, I can know things 10 minutes ago about the position 10 minutes ago of a certain billiard ball that are in no way parasitic of my knowing anything whatsoever about what happens to that billiard ball between then and now. Okay? Why can I have such knowledge? That refers to cases in which the knowledge is stored in some other system, okay, in some recording system. In order to know that the recording is reliable, of course, I need to know stuff about what happened to it between then and now. Nobody toyed with it, nobody doctored with it, but it is completely and radically independent of whatever I may or may not happen to know about what happened to the object of interest between then and now. That's never true toward the future, okay? Anything I know about billiard ball number 5 10 minutes from now is necessarily parasitic because it operates by way of prediction on stuff I feel safe in inferring about what's going to happen to the object between then and now, okay? It seems to me that if you take this observation really on board, it goes a very long way towards explaining the impression, okay, that, how do I want to put this?
Time is asymmetric.
What?
The time is asymmetric.
Well, but the time is asymmetrical in a particular way. That it's earlier times that, as it were, generate the situation at later times, rather than the other way around, okay? Let me see if I'm so nearly incoherent at this point. Let me see how I put this better. Let me see how I did put this better. And then, as I said, I would stop. So, oh, right. Okay, good. So here's the deal. Here's a more suggestive way to put it. What this asymmetry, the impression that the sort of psychological impression that this asymmetry, it seems to me, very strongly produces, okay, is the idea that the idea is nothing that happens to this billiard ball here. You know, I can be in situations where my epistemic access to this billiard ball back here is not at all parasitic on knowing anything at all about what happened to it in the intervening interval. Okay. The impression that goes with that is that stuff I do here doesn't affect what happens to the billiard ball back there. Okay? Whereas I can't know anything about the future of that billiard ball that isn't parasitic on my having an idea of what gets done to it in the interval between now and then. That brings with it the impression that what this billiard ball is doing here is generated by what, among other things, I might decide to do to it or not to do to it in the interval between now and then. I'm sorry, this is being extremely badly explained at the moment because there's only so much my neurons can do right now. But there's another story to tell about how this other epistemic asymmetry feeds into the very strong impression of a corresponding causal asymmetry. But I think I'll leave it there. Yeah.
I believe we're going to eventually be discussing the supposed fine-tuning of the
We are.
fundamental constant.
Yes.
Because we are going to, I'd like to be assured that the previous example about entropy, why I believe that we started off with low entropy, I understand that.
Right.
Implied that that was unique.
What
It probably
implied that
is.
what was
I can't think of any other solution, but
Oh.
I could be a magician, and last week I changed the number of roots from 1 to 2, and I mean all of that's quite implausible and be hard to tie together with everything else we know about life. But it might be that there's some strange combination of events that I can't even think of, the different fundamental laws, the whole kind of thing that can still result in. It's very unlikely.
Yes, of course. No, sure.
It's just not unique, what we
Yeah.
think it is.
No, of course not. I mean, we don't have any reason to believe that the theories of the world we're entertaining now are the only possible ones or the final ones. That's a very it's not just a statement about this. That's a statement about science generally.
It's the most
Of course, that's true. I mean, the relevance of what we've said over the past 2 days to issues of fine-tuning, I think mostly has to do with the nature of the original, of the probability distribution over initial conditions, okay? That is, there was a discussion about whether one ought to regard that probability distribution as justified in the way that other scientific laws are by its empirical success, or justified in some other way that transcends just those considerations, that has something a priori-ish about it, or something like that. Which attitude you take is going to make a big difference in how you feel about issues of fine-tuning, okay? Because worries about fine-tuning get raised by statements like, look, we have good reason to believe in a certain picture of the world according to which what we see is highly unlikely, okay? So we've got ourselves a problem, okay? And if you're convinced of the sort of epistemic foundation of all these claims we make about the world, a statement like that is going to be at least puzzling, okay, at the outset. Because you're going to say, what the hell kind of good reasons could you have to believe in a picture of the world which, according to which the universe we see is highly unlikely? You've got some source other than the universe for your beliefs about what a well-justified fundamental physical theory looks like? It isn't that there couldn't be any conceivable answers to that question, but that's a kind of question one is going to want to ask and one is going to want to press on people who think there are various puzzles about fine-tuning. There are plenty of people, actually, is Craig gone? Craig is gone. But Craig said he's going to mention this when he speaks tomorrow. There are people like Hugh Price, at least who at certain times in his career thought there was a big puzzle about the low entropy initial condition of the universe, the thought was the low entropy initial condition is highly unlikely. Why, relative to what probability distribution is it highly unlikely? Well, I guess the thought was it's highly unlikely. Actually, Tim, there are people who entertained such things. I guess he thought it was highly unlikely relative to the probability distribution that was uniform.
Don't blame it so much on Hugh Price. I mean, Penrose had that
That's
picture
true.
in the
Okay.
Emperor's New Mind.
So I guess the thought
Brian
was,
Greene talks about it a lot in
Is that
his second
true?
book, in his second.
How's
the
this
second?
I guess, anyway, there are people who say there's some big mystery because the initial state of the universe that we see is highly unlikely. You say to them, how did you figure out that it was highly unlikely? Well, they say, well, I take it that the right thing to do, you start with the probability distribution, which is uniform over the entire phase space. You say to them, how come you decided that? And they say something like, what do you mean, how come I decided that? It's obvious, or something. What else would there? What else would be fair? What else would be proper? How else should you start out in the absence of any knowledge whatsoever, or something like that? And you say, so you seem to have some other way of determining what the correct probability distribution is. You seem to have some other way in mind of determining what's probable and what's not probable. That's distinct from looking at the world, okay, and learning about what's probable and not probable by ordinary empirical scientific investigation of the world. It seems to me that there isn't any such puzzle, okay, that there isn't any crisis of the form the low entropy condition is highly unlikely. It's not unlikely relative to any probability distribution that we have any good scientific reason for believing in. I would claim that the probability distribution that we have a good scientific reason for believing in is one that assigns probability 1 to the initial state being a low entropy state. That is the probability distribution characterized by what I was calling the mentaculus earlier on. Yeah.
So suppose someone were to say, why doesn't the argument you just gave generalize in the following?
Why doesn't the argument?
Why doesn't it generalize? The argument you just gave generalize in the following. You look at violations of Bell.
Right.
And when we look at that and we say, gee, what Bell showed is some non-locality. And then some guy comes on and says, no, I have a completely local theory that'll make all these predictions. It just requires the very particular initial condition.
Right.
When this guy decides that, now you say, well, gee, that seems kind of conspiratorial and unlikely and implausible.
No.
And the guy says, what do you mean? Where are you getting your sense of what's likely and unlikely?
What it seems like is a bad scientific theory because it's extremely complicated. Okay? That's what it is. That's what the situation is.
That's not what most people would say. And they
That's
might
what I
say
would say.
we have lots of, we can derive things about reasonable, look, you can get a reasonable sense of what you think of as good measures and so on from the microphysics, and then, boot those up and apply them to the macrophysics and apply them to larger states, and find the larger states are really on those measures very unlikely in some way. I mean, it just seems to me it's much too quick an argument. It's as if you're saying, no matter what physical theory we derive, ipso facto, it's going to turn out the universe was likely. Right? It has to be, because what else could likely mean but, what else could probably mean but like the universe we see? And it seems like, you can come up with theories that just seem to have conspiracy.
No, wait, it's definitely, as you know very well, it's definitely.
No, you should be agreeing with Tim on this one.
Well, wait, hang on a second. No. I'm agreeing with large chunks of what Tim says, but I mean, anybody who has an even remotely Humean account of probability, okay, for anybody like that, it's ruled out by definition, okay, that the totality of the universe is extremely unlikely, okay, because in that case, the theory according to which it's extremely unlikely isn't a good summary of the universe.
If your argument is that you could extremely unlikely.
No, that's right. No. You have to be careful about which variables you're talking about and so on and so forth. But I mean, looked at in the appropriate way, okay, what it is for a theory, probabilistic or otherwise, to be a good scientific theory. What it is for a set of claims about the world to constitute the laws of that world is for them to be a good description of that world. In a world, if you consider a world where every coin flip comes out heads, okay, the law that the probability of a coin flip coming out heads is a half is not a good summary of the facts of that world.
So if all of this was preface, if you're a Humean, if
Right.
you're like me with a whole bunch of other
Right.
commitments, how could you think that? That's
Right.
just a different claim from how
Fair
would
enough.
anybody think.
Absolutely.
I mean,
right.
David,
Fair enough.
you're
Yeah.
not, let me just echo Tim again. You're really, maybe one has to take it on a case-by-case basis.
Right.
The way you put it in such broad generality, people worry about naturalist problems. It's not so much just that you have small probability in some naive way. It's that things in some sense, which maybe it's hard to specify, really do look conspiratorial. They look in such a way that they seem to demand some explanation. You're not doing justice. You're not to these concerns. I'm not.
No, I think I agree with those concerns. This gets back to something we discussed earlier, I think, okay? We have very deep intuitions about, so here's the claim. What's conspiratorial, what's coincidental, what's crazy, blah, blah, blah. All of those decisions are made by, at the end of the day, by the probabilities in what turns out to be the correct fundamental theory of the world. A lot of those...
Not only that.
Well, hold on one second. I mean, this is going to just recapitulate the discussion we had, part of the discussion we had this morning. Because you're going to say to me, David, you're not being honest. You would react to certain things as conspiratory, okay? And I'm going to say that's right. But my diagnosis of that reaction is going to be that I have internalized certain aspects, okay, of what in fact the probability distribution is. Okay, and that's going to lead me to judge those things. That is, here's the question. There's no dispute about the fact that I'm going to judge them as conspiratorial. Okay, the question is that judgment somehow being made a priori in terms of some a priori conception of what's conspiratorial or what's not, or is that judgment somehow influenced by my experience of the world? Either my own personal experience of the world or the experience of the world of my biological ancestors that was hardwired into their DNA, or the experience of the world of my teachers, or something like that. I completely agree with you that I'm going to have the same reactions as you are to certain things looking conspiratorial. But it seems like you're committed to something more than that. That those experiences those reactions don't take the form of abstractions from my earlier experience, or of being conditioned to feel that way by natural selection or something like that. That there are things that are objectively a priori conspiratorial.
I don't
see why you think that.
I'm not making any claim about that. I'm just saying that when you describe these people concerned about strikingly strange, whatever, initial conditions, you present them as, to them it does seem, not just they're unlikely, conspiratorial. Right. You know, John Brickman likes to say, suppose we found out that the initial distribution of matter in space was provided a picture of Elvis Presley.
Right.
We might be puzzled about it.
Right.
Well, we might think that's a great theory.
I agree with that completely. There are certain things that might look conspiratorial. Take, for example, to discuss a concrete case, take something that lots of people really have been concerned about, the low entropy initial condition.
Yeah.
Okay. There are certain measures, certain easily specifiable measures, by which that looks wildly conspiratorial. Okay. Moreover, it's easy to diagnose why it would even look conspiratorial to us before further reflection. Okay? Because I think Tim said something like this earlier on. We're used to looking at isolated macroscopic systems. We know that for the purposes of predicting the future, taking a uniform distribution over the microstates compatible with the macrostate of those things works well, okay? One way to generalize that is to think of a uniform distribution over the microstates compatible with whatever we happen to know about the situation, so on and so forth. And you could see somebody thinking, boy, a low entropy state is enormously conspiratorial because it occupies a very, very small region of the phase.
Some people could say.
But then you can come to this guy and you can say, look, I've got a way of explaining all of your intuitions, okay, but which also shows why they're not reliable in this particular case, okay? Why the state of the universe as a whole is special in all sorts of ways, and so on and so forth. I can show you that this probability distribution will underwrite the reliability of using the uniform distribution over the present macro state to infer toward the future, so on and so forth. And I can also show you reasons why you should adopt this, because if you don't, you fall into this, you fall into this cognitive instability and blah, 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 and lots of other of your cognitive procedures depend on it. And you can show the guy that on reflection, the thing to be learned from your experience of the world is not that under all circumstances, the proper probability distribution is the one that's uniform over the entire phase space, but rather this one, okay? And if he still says, no, I have this strong intuition that the right probability distribution is the one that's uniform over all phase space, it does seem right to say to him, where do you think you're getting that from, and why do you so trust, okay? I don't know what the guy might say. The guy might say, I have a strong instinct that pushes me in that direction. If that's what he says, I can say to him, but I can show you how that instinct arose in you in a way that isn't related to the instinct actually being veridical, okay? He might say, it's not a matter of a strong instinct, I have a clear a priori argument that it must be the case. Then I would say to the guy, that kind of argument is not the place to get your judgments about probabilities from. I don't think this is disagreeing with very much of what you said.
It's not, I would say there's too much emphasis on probability because sometimes the issue isn't really one of probability. You could have two small sets, but one could be a really weird one and one kind of normal. There are all kinds of issues. By the way, Sean will be here, in a couple of weeks, and he in his book he also emphasizes one of his motivations is the very smallness.
Absolutely right. We'll have it out with him. Right. David.
Yeah, I mean, just a thought on the third one measure. I mean, his own way of saying, I think what I think he's saying, this what we might think about this probability measure as something which is supposed to be our candidate for the physical probabilities, in which case, your argument just goes very directly. I mean, it's empirically really undermotivated.
Right.
You might imagine trying to think of it as something like Bayesian prior possibilities. But then when you kind of think that through in a bit more detail, it starts sounding completely nuts. I mean, if you imagine prior to opening your eyes, have a quick chat with God about your prayers, and God says, well, just for curiosity, what prayer did you put on the universe being filled with an unbelievably hot plasma? And you say, well, my prayer probably was that 1 minus 10 to the power of 10 to minus 23 or something. I think God might look at you a bit strangely. Why on earth did you start off prior to opening your eyes being quite so damn certain the universe had this particular construal? So I mean, on either of those ways of getting it prior, that's probably very hard to see how you feel in the details.
Yeah.
So I want to ask about the Cosmology.
About the what?
The Cosmology.
Yes.
So the past hypothesis seems to limit influence on the past.
Yes.
And maybe make it practically usage.
Yes.
But it doesn't rule it out.
Yes.
So do you endorse that causation?
Yes. So there's a long story there. There's a lot. There's been a good deal of literature since this basic model was first proposed, where people, in the most interesting versions of it, people said, okay, but what if it's the case that you actually are lucky enough that the thing over which you have this direct and unmediated control is billiard ball number 5 itself. Okay, and there are people who try to. There are a couple of papers by Matthias Frisch where he tries to come up with psychologically not wildly implausible cases like that, and I think those are really interesting, and I think that that at the end of the day, this is something that I initially had a reaction to. Then I decided, basically because Allison wrote a paper criticizing my initial reaction to it, and I thought she was right. So I changed my mind about it. What I think ends up happening in cases like that is that you need to, so I think in the Frisch cases, I'm sorry, I'm very tired of being incoherent here. Here's what I think happens very briefly. I think that Frisch does point to cases where if you grant him the psychological plausibility of these cases, I think one could probably dismiss them as psychologically completely implausible, but forget about that for the moment. Put that aside. Suppose you grant him the psychological plausibility of these cases. Then he does come up with cases in which something that phenomenologically feels to me like a decision turns out to be something on which certain features of the past counterfactually depend. Okay? Now, you may want to ask a further question about the relationship between this kind of counterfactual dependence and something you might want to call control. Okay? And there are things that you might want to demand of control that exceed the demands you would just want to make of pure counterfactual dependence. And at the end of the day, but this is quite a long story and there's a lot to say about it, and I think Frisch's examples are really interesting. At the end of the day, it seems to me that the right thing to say is going to be, if you grant the plausibility of those cases in the first place, that Frisch does show that there are cases where certain features of the past counterfactually depend on certain activities of my brain now that look to me, that for me have the phenomenology of decisions, okay? But that they won't amount to anything you would want to call control. You need a little more in order to have control over something like that. So yeah, this argument goes piecemeal. Okay, that is just the first part, the first step in the argument, which is all we went through today, was a step that shows that although so I don't want to use handles anymore. That although these things such that if you had direct and unmediated control over them for affecting the future are plentiful in the present, vis-a-vis affecting the past, they're much, much more rare and far between, so that you could make use of whatever it is that you have control over, direct and unmediated control over in the present, to do all kinds of things in the future, very little toward the past. Then somebody might say, little schmiddle, what if you're lucky enough?
False memories, yeah.
What if you're lucky enough to have that kind of control over one of those rare features of the present? Good. Then you need to argue further, and you're going to need to make a distinction between counterfactual dependence and control. And the thing keeps developing. I mean, it's a long, fairly intricate story. As far as I can see, thus far, it all hangs together very nicely in the end. But there's a lot more to say about it than I've had a chance to say here. Yeah.
I'd actually like to suggest that we move to allow him to reject Causal.
Oh, that's a good idea. Okay, good. Let's do that.